The conveyor station we're using comes equipped with an optical proximity sensor, an optical through-gate sensor, and also an inductive proximity sensor. So as you can see, the optical proximity sensor will pick up either the metallic or the non-metallic workpieces, whereas the inductive proximity sensor only picks up the metallic pieces. We can tell when the sensors are triggered based on the convenient lights, and those are also quite useful for troubleshooting. Now, viewing the station from the side, we can see that our motor is connected through two electromechanical relays. You can see those here on the machine, and those have override buttons. So we can check the functionality of those electromechanical relays. So we see if one is pressed, we get a click but nothing else. If the other is pressed, we move forward. If they're both pressed at the same time, we get reverse motion. This is because they're connected in an H-bridge configuration. So one of the relays is controlling the power and the other one is controlling the direction of current flow. Now that we've become acquainted with the system, I'm going to go ahead and open up the FluidSIM 5 software. And this is what we're going to be using to program our station today. I'm going to start off by adjusting my sheet size. This is completely optional. It's just a preference. I like to adjust the sheet size so I can use more of my screen without getting error messages. And I'll save my project. Opening up my component directories, I'm going to be using just electrical components today, as there are no pneumatics on the conveyor station. To my project, I'm going to add the multi-pin distribution plug. This is basically the way that we connect all of our input and output devices on the conveyor station to one serial bus, which lets us connect other controller hardware to actually control the hardware itself. So I have added to my program the 24 volt and 0 volt lines that simulate my power supply that would be on the physical machine. And now I'm adding a detented switch, which will be used ultimately to be able to connect and disconnect power from my circuit. Now to my circuit, I'm going to add my measurement devices or my sensors. These are going to be my optical proximity sensor and my inductive proximity sensor. Notice that I'm going to name these as I add them to the program. I'm going to use the same names in the multi-pin distribution plug to connect the sensor itself to the physical hardware. So I'm going to make sure that I put those same names in the ports where these are actually plugged in on the physical device. Now on this circuit, we see that the top lead represents the brown sensor wire, which is the power line. The bottom represents the blue wire, which is the ground line, and the black, or the line off to the side, is going to be my signal. Now I'll add to my code my inductive proximity sensor, which is going to be organized in exactly the same way. So this completes the sensor part of my circuit. So now if I run this, I can actually watch power flow through my circuit. And more importantly, when I activate the sensors on the physical machine, they actually will light up on my simulation as well. So now in the second part, I'm not going to need the sensors, so I'm just going to go ahead and remove those from my file. Now to the file, I want to add my motor. And it's important to note that the motor will not cause the actual physical system to move, because it's the relays that are causing the motor to move, not the motor is causing the relays to trip. So what I want to demonstrate here, however, is that I can see what direction my motor is going to spin. So here my motor was spinning counterclockwise, and I see that if I reverse the flow of current through the motor, I'm going to get an opposite direction of spin. And I feel like it's pretty obvious why it is that we wouldn't want to have to rewire our motor every time we want to change the direction of it. Thus, that is where our electromechanical relays come in. So for the sake of explanation, I'm going to build this H-bridge circuit up slowly. So I'm going to begin just using manual switches. So initially we will operate this by hand, but ultimately we want this to be controlled by the electronics. That means that those switches will have to be somehow controlled using an electrical signal. And this is what relays are spectacularly useful for. It's also important to notice that the switches that are closest to the motor that are controlling the direction of current flow, what I'm calling reverse here, are 2-position switches. And that's important because I'm going to be creating 2 different paths for current to flow through the motor. So here I'm just demonstrating the first path for current to flow. And we see that the motor does turn on, but in the second position, obviously it's not connected to anything, so nothing's going to happen. So now I need to connect my second path. Basically, to do this, we're going to take the second position on each of those 2-position switches and attach them to the opposite side of the power supply. In testing this now, we can see that we can use the start switch to enable power to the circuit, and we can use the reverse switch to reverse the direction of current flow through the motor, so the motor will spin forward and backward. Now, using the same basic principles, we can apply instead relays to control the switches so that we can use an electrical current to control the direction of current flow through the motor. In our case, we're still going to need some programmatic way of commanding the relays. Normally you would do this, say, with a PLC, but in this case we just want to push the buttons, so we're just going to add in here 2 manual switches to control power to each of those relays. And I want to point out here too that we are using separate power supplies for the relays and for their connected switches. So another thing that electromechanical relays in general are useful for is electrical isolation. So I can use a small current or a small power in order to drive a much larger load. In this case, they happen to be the same power, but they wouldn't have to be. Note also that I'm using general switches, not manually operated switches. And I'm just going to speed this part up because you guys already watched me build this circuit one time. The only difference is now I'm using the general switches instead of the manually operated switches. The other difference, because I changed those switches, is now I want to link them to my electromechanical relays. So notice that I am naming the relay the same thing as the switch, and I'm giving the same name also to the output ports on my multi-pin distributor. Finally, now we've got it all hooked up and we can demonstrate how this works. So I've got my separate circuits, I've got everything linked. I can turn power onto the circuit and I can reverse the direction. And forward and backward. So that pretty well does in the demonstration. Thanks again for watching. See you next time.